Okay, hello, welcome everybody back after lunch. My name is Bart Oldeman and I'm going to talk about bubble wrapping, EasyBuild, and other ways to stage installations. Just a few slides of background. Like I am coming here as an employee of McGill University, but I work with Calcul, Québec, and Digital Research Alliance of Canada, where we kind of manage the academic supercomputers of in Canada. And we are installing software on them via CVMFS, uh, coordinated by the Research Support National Team, of which we have software installation coordinators like Maxime Boissonneau, Charles Colomb, and Doc Roberts, and myself. And then Ryan Taylor is doing more of the CVMFS plumbing parts. So you see here that we are a hugely distributed organization with regional partners. So I am with Calcul Quebec, but then there's Compute Ontario and Ontario. On the east, we have AceNet, Atlantic provinces. And on the west, we have both BC, British Columbia, and Paris, DRI. 250 tech, I think we now have 400 people working within the Digital Research Alliance of Canada, almost 20,000 user accounts, 6 clusters, almost 1 million cores combined, and 3 extra researchers at the Canadian institution. And we've just been through a renewal. Last summer, we went through production of new clusters. So we used to have clusters Cedar, Graham, Niagara, Beluga, and they've been replaced by Fir, Nibi, Trillium, and Roccal, and they all have now pretty much all 192 cores per node and H100 GPUs. Still, the Naval is slightly older, it's A100 CPUs. And so we have a lot more cores than before and double the storage as well. So that's on the hardware side. And that's basically distributed among a few main sites. So here on the left is Vancouver Island with a cloud system called Robutus. Then in Vancouver, we have Fir. And then in Ontario, Southern Ontario, have Waterloo with Nibi, and Toronto with Trillium. And then in Montreal, where I work, we have Naval and Roccal as our mammalian clusters, which all have the same software stack. So doesn't matter which cluster you log into, you have a similar module interface. And the way, and this is why I'm getting into the bubble wrapping stuff, is that we have a system for publishing software which is quite different from Easy. You say that the Easy system is a bit better, but it's more distributed. So we have like a single cloud system, which is basically a cluster in the cloud, a Magic Castle. You may have heard of that before. It's basically a system where you can use Puppet and other systems to basically describe a cluster, and you run it, and after a few minutes you have your cluster in the cloud, and it just kind of works magically. And so we just log into our build cluster, we go in the login node, and then it just looks like any regular cluster. You can salloc via an interactive job to a compute node, or you can use -- job with EasyBuild and run your code on the compute node. But what's important here is that you can run it as a regular user, install something in your home directory, or even do -- prefix with /tmp, or you can get as the result your official build, which then goes onto /CVMFS. But this /CVMFS is not an actual CVMFS mount, it's just a regular networked file system. So it's a read-write copy of CVMFS. And so it's like our pretend CVMFS, which is really a parallel file system where you make install targets into, and then we can SSH to our publisher node, where this mount point now sits under /CVMFS ceph with an underscore, and then we can actually rsync from that particular place to the stratum 0. So, and that's where we have our bottleneck, because cephfs can be slow. And that's why I mentioned last year I had a side talk at the EOM in Jülich, and we found out that CFS can be a bottleneck, and for some software it basically took days to install and then sync to the Stratum Zero, and maybe we could use Aptainer or Bubble Wrap to speed this up. So that's what I mentioned last year, and now I've actually done it. So I'm going to talk about that. And at the same time, we had Sam Moores in Brussels who said, hey, Bubble Wrap is also a good idea for different reasons. So I'm going to talk about that too. Now, what's the idea? And what's the idea of the Bubble Wrap solution? But basically, the general method is called a staged installation. Because what EasyBuild does, and I think SPAC as well, if I understood the SPAC correctly, is you basically install the software directly into the target location. But if you look at any, I'm not sure every Linux distribution, but basically all the common Linux distribution, they don't do that directly. They use a two-step process. You create your RPM, and then you install your RPM. If you use Gen 2, it's a from source distribution. It doesn't install directly in the final location. It first stages it into some other place, and then it installs in the final location. So it's a two-step process, and it's what's used by Linux distribution. And also, if you're using CVMFS, you basically have to use a staged installation because your push step into CVMFS is going to be separate from your build step. Nobody is going to do make install and directly install it into the Stratum Zero. I mean, I guess you could, but people don't really do that. I don't think Valentin would approve of that, but he's shrugging, so why not? Yes. Okay. So Easy uses some kind of staging using a build container in the UnionFS. Getting into that later, an EasyBuild 5.3.0 can do the staging using the new --b wrap experimental option. So it's okay, I lost power. I'll survive. So this is it's a double step. We have our easy config. EasyBuild installs the greatest software ever, but instead of going into your install there, you prefix by some path, and it goes to a separate place, and then you copy it to the final location. So basically, I should display this video. I just like Bubble Wrap. You can pop it. It's an activity that you can do when you're stressed. Anyway, so the other reason that we're having, which is nothing to do with a slow CFS file system, is that we can say, what if we already have a software that's available? I think that's what Oldeman mentioned as well, and we want to reinstall it because there's a bug fix or something else changed. What happens in EasyBuild, it just wipes out the existing installation and then reinstalls it. And so there is a bit of a downtime for that software. And so can we improve that process? Well, we could. We can say, okay, let's install it to some temporary location, and then we make the reinstallation as quick and painless as possible. Maybe having 0 downtime, maybe having downtime of 1 nanosecond. Oops. And the reason too that this is about the speed, so we see this the CVMFS file system is on our system visible on all the compute nodes and publisher nodes, and it's painful on large binary installation. And we don't put that on our public repository. We also have a private repository that's only mounted by the clusters and some trusted computers or small clusters. It has all these binary installations like MATLAB and ANSYS and things that we cannot publish publicly because of licensing restriction. And some of these packages are very large. MATLAB, single installation, 700,000 files, 23 gigabytes. ANSYS, a little bit small in terms of files, but still 155 gigabytes. It installs the whole world. Quantum ATK, only 100,000 files. I'm just putting it there because I have some benchmarks on it. And what we're doing is that we have a compatibility layer. I talked about this before, it's similar to Easy. And the binaries, we want to link them to the glibc that we provide via the compatibility layer. And we do a bit of patch elf on the binaries, but we do a scan. And we do that scan on the CEFFS. That takes a lot of time. Then we copy it again to the Stratum 0. It takes a lot of time. Much faster to do this operation on the local file system. So here's some quick benchmarks. So it's just a random tarball. Try to untar it, the TCC with about 100,000 files. And same for a binary package called quantum ATK. It just happens to have about the same number of files as that TCC tarball. And see that on a local SSD, it goes extremely fast, like unpacking TCC, 6 seconds. And on CEFFS, it could take 30 seconds, but that's on a very new CEFFS that we just got like a month ago. But we had an older CEFFS that was still running on spinning RUSC, like older hard drives. And then we had competing networking groups on the neutral nodes, and it would sometimes slow down into a crawl, and it would take like 900 seconds, which is 15 minutes to unpack the TCC tarball when it would take 7 seconds or less on a local SSD. It's like you could wait for days on like ANSYS or MATLAB. And so the similar scaling we could see on EasyBuild doing the quantum ATK. So even on the SSD, it takes a bit more overhead, but you're still having similar orders of magnitude going from a local installation to a CEFFS parallel file system based installation. Now, how do stations, like I said, Linux distributions have been doing this for like 30 years, pretty much. And they didn't have the benefit of having bubble wrap or other kind of tools to automate that. And they do it manually using what is called destir. So you see that all these common tools like Automake and CMake and Meson and things like that, they understand that you can put destir, make install destir equals the build root, and it will just work as long as the build system understands it. But we are dealing with exotic scientific packages that may not understand destir. So it's not a catch-all. We don't have a nicely written packages that are already in Linux distributions. So they don't typically always support destir. So I put on a link to some essay from 2011 about automating destir. There's a lot of details about how this works and what kind of workarounds I had back then, but it was all suboptimal. What does Easy do? So Easy has a very complicated apptainer command to use union fs, and before that you use overlay fs inside the container, and that way they can pretend to have CVMFS mounted in the container mostly, but it's also partly read-write, and then you can install your software inside that container, and it will work, and then afterwards they create a tarball and push that into CVMFS. And the advantage, of course, of using apptainer for this is that you have a consistent environment, because whether you use apptainer on your laptop or on a cluster somewhere else, you have the same operating system inside apptainer, so the easy installation should be the same. Then we have the step 2, which is the thing is we have it installed in a separate location. How do we get it to the original location? So Linux packaging managers have to do that, and instead of looking at RPM, I looked at Gentoo Portage, I checked out the source code, and I looked at how does it basically install a new piece of software. And you've done like an update of glibc on a running Linux system using rpm-i glibc or whatever, or apt-get or dpackage or whatever, and it will just keep on working. There's no downtime. So how does the magic work? So basically, For Gen 2, it is all written in Python. It uses something called filecomp.cm.comp, and it checks out if the files are identical. If they're identical, you don't have to do anything. And if they're not identical, you use rename. So it's a syscall. It's a very nice syscall because if it's on the same file system, you move the file, then there's no time that the old file, that neither the old file nor the new file exist. So the process that still have the old file open will see the old file, and new processes will open a new file. And the old file will basically stay on the old file will stay on the file system until the last process that has the file open dies. And you can still see those files and even recuperate them from special proc file, proc PID FD, and then you look at the file descriptor and you can see the file with deleted in brackets and recuperate the file as long as some process has it open. So that's what Gen 2 does in Python, but you can sort of do it with rsync. Rsync from the bubble wrap directory to the original directory. This does a copy and a checksum. Should be fairly reliable. The checksum, in theory, is not as reliable as doing a full file compare. And what Sam's going to show later is to do a directory move. That's the advantage that the original directory can be moved into a backup location. Then you can optionally keep it or remove it. There is a nanosecond of downtime there because there's a slight period where neither the old nor the new directory exists. Now, finally, bubble wrap. So what does bubble wrap? It's like I see it myself as like a very, very mini, very lightweight container. But it's basically described as a sandboxing tool. It uses Linux C groups, and we use it to just manipulate mount points. So we just basically change the file system inside our user namespace. It can also use IPC, PID, network UTS. Did you know what UTS means? I had to look it up. It means Unix time sharing, but basically it refers to the host name. So inside your user namespace, you can change the host name of your computer. And when you quit it, it's back to the original host name. And so the syntax here, the bwrap -- defbind, defbind // means I'm copying the host file system completely to the file system in my lightweight container. So including the /def device file system. And then the -- bind basically says which paths I'm going to change. So in this case, what looks like path to software name version inside the container is actually the bubble wrap, the special bubble wrap name outside the container. So we're having two paths. We're having like a temporary location, and then inside the container, we see it as the what EasyBuild thinks it is, what is the original location. But EasyBuild basically fooled because it's writing into a different location. Now, sometimes that doesn't work because what I'm seeing sometimes is that the path to the software does not exist yet because it hasn't been created yet for a new piece of software. This is not a reinstallation, it's just a complete new piece of software. And then I have to use a different syntax using overlay, which is a little bit more similar to what Easy does, except using overlay FS and obtainer. Bubble wrap can use that, and then it can basically create the new directory. So the reason for that is rather technical. I'm not going to get into too much details, but what I'm having is that the first method has been implemented in EasyBuild 5.3.0. The second method has not yet, but I have a pull request open, and it just needs a bit of functionality on the test nodes to get that merged. But only if the first method doesn't work, I'm falling back to the second method. So that's okay. So the way that was added to 5.3.0, you can use that now using EB -- experimental -- bwrap, and then you put location where you want your temporary installation installed via -brep -install path. And that's in a pull request. And it needed, like Kenneth was saying yesterday, it needed some easy block adjustments because some easy blocks were basically trying to wipe out the whole installation directory, including the directory itself. That was then failing, so I said, okay, instead of removing the directory, we will just clean it. And so that's only needed for the software. For the modules, we don't really need to bubble wrap. We can just put a separate location. And also he puts in a JSON file with some information. Oh, I need to wrap this up very soon. So basically, the second step for CWF is slightly different. We don't need to worry about overwriting the existing installation, but we do need to create some kind of tarball. And for that, we still use the CFS file system, but it's like a streaming tarball. It's way faster than a parallel file system. So we have a little overhead for creating that 1 minute to create a tarball, 1 minute to unpack it. It's still shorter than the difference between local and shared. Then we sync it to the CVS startup 0. We could ingest the tarball just use directly. This is special CVS functionality. We're not using that because that's not really in our workflow, but Easy does that with a tarball. And EasyBuild can also create a tarball itself, in theory, using packaging support. That looks to me a little bit bit-rotted, and the problem is that it does the packaging a bit too early because it misses the EasyBuild directory and the reprot files, which I actually like to have, and they're just not there. So maybe if I have time, I can revive the packaging support a bit. So in our present state, we're so far that the restricted repo is no longer on CFS on our new on the new cloud. So we have our whole installation of MATLAB and ANSYS automated via bubble wrap using EasyBuild 530. So woohoo! And now I can give the mic to Sam to give a demo of the EB530 functionality.
Hello, do you hear me?
Yeah, sound is fine.
Sound is fine?
Yeah, I just need to stop sharing. Oh, I'm done.
Okay. Trying to share my window. Can you see it? Yes. Okay, so hi everybody. I'm really sorry I can't join you. I hope you're having a really good time there in Portugal. If the weather is bad, then just come to Belgium because it's really nice here. Okay, so I'm going to do a really quick demo just to show how to use EasyBuild with PWrap, so the thing that was implemented in version 5.3.0. Okay, so what I have here, I have this script that I will source. That's just to set up EasyBuild for me. So I'll show it. So it's not very important. The most important thing is the first line that will show me where is my install path. So this is the install path that we want to have our installations to be in the final stage. Okay. So let's just try to install something. Yeah, so I'm going to install libpng here. And let's first check if it's already installed or not, and if there are dependencies. So you can see I have here libpng and zlib, which are both not yet installed. Right? And then I can install both with PWrap. here it is. So this is the command I use, eb, the name of the easyconfig file, --brep. Then I have to specify the brep install path, so the place where it will actually be installed, not the place that EasyBuild thinks where it will be installed. And then I have to add the option -- experimental, and then also the -- robot, because I have to also install the dependency zlib. Okay. So what we see here, oops, sorry, I'm doing stupid things. So you can see that EasyBuild starts, it creates a temporary log file, and then it immediately removes this temporary log file. And why is that? Because EasyBuild will relaunch itself, and then it will relaunch itself with brep. So this command will be prepended, prefixed before the eb command. So you can see the brep -- bind, what Bart explained, and then the bind options, so the paths that will be changed. So we will change the lib.png install path, and we'll also change the zlib install path, right? And then EasyBuild will also create the JSON file. The JSON file contains metadata, so you know where the final destination will be and how to copy them. And then EasyBuild will also add 2 extra options, namely the disable brep, because now we don't want to relaunch EasyBuild. We want EasyBuild to really install itself, install the software. And EasyBuild will also add this install path models option, and this is for the models installation that doesn't need to be brep'd. Okay, so as you can see, it's already finished. I can, oops, why isn't this? So we'll quickly go over it. So it will first install zlib, just in a normal way, like it always does. And then it will install lib.png also, and then everything is finished. Okay. So let's look where everything is gone now. So you can see that we have our eb install directory, that's the final installation, and then the eb brep directory. If we look at the eb install directory, we have the models and software, but if we look into the software directory, we can see the lib.png, for example, but it's empty, so nothing is installed there, and the same is true for zlib. And then if we look into the eb brep directory, there we can see the software for lib.png, and you can see that's indeed installed here, right? And then the brep JSON file looks like this. So it's just the brep command, EasyBuild options that we used, install path for the models, so the final destination where the models have to go, and the final destination for the software, and then the models that have been installed. So you can use this in the second stage to get it installed in the final location. Okay, so what is left to do is to do the second phase. So Bart already explained the options that we can use. I will here quickly show how you can do it with the move, because the move is actually the easiest thing, and maybe it's also the cleanest thing, because if you will replace files one by one, then at some point in time you will have like a mixture of the old installation and a new installation, which might also not be ideal. So, and the move is very fast, so in most cases I guess that will be sufficient. But also, as Bart explained, it's important that the move is done in the same file system, because If it's in the same file system, then it will be a rename, and then it will be atomic. So how do we do that? So yeah, so we first move away the original installation. In my case, this directory is empty, but it's not always the case. So we have to move it away because otherwise we cannot move the new one into it. And then we can do the move. Where is it? Then we can move from the vrep directory into the install directory. Right? Oops. No. Move. So if we make sure that these two moves are very short after each other, then we minimize the downtime for this software. And then, of course, we also have to do the same for the models. But for the models, it's a bit easier because we can just override the first file with the other one. So where is this? So we can just use this command. Oops. And this will not work because we first have to create this directory. And then we can do the move. Voila, that's it. And then the same has to be done for the zlib, of course. That was my demo. Thank you. Yes.
And then your existing installation will appear to be owned by the nobody user, and you're not able to remove it.
Oh, yeah. Okay. Yeah.
And that's why they're kind of mutual exclusive. So I actually tried to use overlay, and then I ran into this issue.
Yeah. Yeah. I think we've seen similar things. I actually have a short second question.
So I'm not sure if it Aptainer it works around that somehow. I'm not sure how you guys do it in Easy, but
yeah, we had, well, I mean, with rebuilds, we have seen issues with removing old
Okay.
installation paths as well. We sometimes do
Okay.
it manually before we start
Yeah.
the build. The other question I had was, why don't we do the move already automatically? Like, or at least give the option to the user, like, I want to do the move anyway. Now it's a manual procedure at the end.
Yeah, it's just a not yet implemented
Okay.
issue.
Okay.
Yes.
So no fundamental reason. I mean, it's nice to be able to do it separately, right? Because
Yeah.
then you can still like do it as a CVS ingest or whatever
Yeah.
you want to do as a deployment in the end. But
Yeah, because I mean the move is like we have a wrapper for EasyBuild, so I'm just having in the script past the where I call the real EasyBuild, I just have the tar commands.
Yeah.
So yeah.
Yeah. You can't do the move atomically unless it's on the same file system.
Well, yeah, we have to basically figure out the best way to do the move is the simplest way, but it's also not entirely atomic because you have this nanosecond where neither exists.
if you go back.
No.
If you keep back.
No, even with the backup, there's just a split second between the two moves.
But you can do one move, no? You can just override. I mean, now you decided to back up the old installation.
No, but you
No,
can't
no,
do
no,
that
no,
on the
no.
directory level. You can move files.
Ah.
But well, we should wrap up. But I think the next step, it's an experimental feature, so it's not done. The next step would be, I think, to maybe even give like an EasyBuild option to tell EasyBuild now move things in place and use this method, move or sync, whatever, and just give the option, and you can figure out what works best.
It's basically something that we have to figure out the best way. Maybe doing it on a file level is not so bad because it can be atomic. If it's on the file size, with the directory move, you still have this little issue.
Yeah.
Yeah. Well, you copy to a temporary file and then move it. Yeah. Takes more time.
No, switch automatically now.
I was looking for it.
Clip it all.
Yeah, just as a little not seeing what I'm doing. Yeah. Do it like that. Put it the wrong way around now, sorry. There you go.
Okay. Where is
Yeah. Just need to push the streamline.